April 17, 1943. Guadalcanal. A maintenance hangar baking in the South Pacific heat. Major John Mitchell stares at a piece of paper, decoded Japanese radio traffic. Admiral Isoroku Yamamoto, architect of Pearl Harbor, will be flying a precise route tomorrow morning. Exact time, exact altitude, exact coordinates. It's the intelligence coup of the war. A chance to kill the man who started it all. There's just one problem. Yamamoto will be 435 miles away. The P-38 Lightnings that could intercept him have a combat radius of only 350 miles. The mission is impossible. Unless Staff Sergeant Marcus Mac O'Donnell can pull off something his commanding officer called absolutely reckless. O'Donnell had no engineering degree, no aeronautical training, just a crazy idea involving fuel tanks designed for a completely different aircraft and 18 hours to make them work. If he succeeded, they'd kill the most important military figure in Japan. If he failed, 18 American pilots would run out of fuel over 400 miles of empty ocean. This is the story they don't teach in history class. The story of how a mechanic with a wrench and a welding torch made the longest fighter intercept mission in history possible. Stay until the end, because what happened in those 18 hours changed the Pacific War forever. Henderson Field, Guadalcanal, April 1943. 6 months after the Marines had taken this miserable strip of jungle and coral, and it was still barely functional. The runway was pure steel planking laid over mud. The maintenance facilities were tents and improvised shelters. Everything rusted in the humidity. Everything broke down constantly. But it was the closest American air base of the Japanese stronghold at Rabaul, 400 miles to the northwest. That made Henderson Field valuable. It also made it the only place from which tomorrow's mission could possibly launch. Staff Sergeant Marcus O'Donnell ran the P-38 Lightning maintenance section. 23 aircraft, various states of disrepair. Never enough spare parts, always too many problems. Before the war, he'd been an aircraft mechanic at Boeing in Seattle. He understood the Lightning inside and out, its twin-boom design, its Allison engines, its quirks and weaknesses. The P-38 was a beautiful aircraft, fast, powerful, heavily armed. Twin 1,600 horsepower engines gave it speed that Japanese Zeros couldn't match at altitude. Its .450 caliber machine guns and 120mm cannon could shred any enemy fighter. Its twin-boom design made it instantly recognizable, intimidating, but it had one critical limitation: range. With internal fuel tanks, a P-38 could fly about 350 miles out, fight for a few minutes and make it back. That was fine for escorting bombers to Rabaul or patrolling near Guadalcanal. It was completely inadequate for what Major Mitchell was now proposing. Mitchell had gathered his pilots in the operations tent, along with O'Donnell and the other senior maintenance personnel. He spread a map on the table. Intelligence has given us Yamamoto's exact flight path tomorrow, Mitchell said quietly. He'll be flying from Rabaul to Bougainville here. He pointed to a tiny island in the Bougainville chain. We have his departure time, his route, his altitude, everything. The pilots leaned in, suddenly very interested. Admiral Yamamoto was Japan's naval genius, the man who'd planned Pearl Harbor, who'd orchestrated Japan's early victories. Killing him would be a devastating blow to Japanese morale and strategy. "What's the intercept distance?" asked Lieutenant Tom Lanfear, one of Mitchell's most aggressive pilots. Mitchell's expression darkened. 435 miles. Each way. The tent went silent. "That's impossible," someone said. "We can't make that round trip. We'd run out of fuel 50 miles from home." "Not if we carried drop tanks," Mitchell replied. Drop tanks were auxiliary fuel tanks that could be attached to a fighter's wings or belly, then jettisoned when empty or when the pilot needed maximum maneuverability for combat. The P-38 had been designed to carry them, but in practice, they were rarely used in the South Pacific. The logistics of getting the right tanks to the right place were complicated. Most pilots had never even trained with them. "Sir, we don't have P-38 drop tanks," O'Donnell spoke up. "We've got some 165-gallon tanks designed for P-39 RE Cobras and some 310-gallon tanks from damaged aircraft, but nothing that's been tested on Lightnings in combat conditions." Mitchell looked at him. "Can you make them work?" O'Donnell did some quick mental math. A P-38's internal tanks held about 410 gallons. Two 165-gallon drop tanks would add 330 gallons, giving a total of 740 gallons. At cruise settings, the Lightning burned about 70 gallons per hour per engine, 140 gallons total. That meant roughly 5 hours of flight time, maybe a bit more if they were careful. 435 miles out at cruise speed of about 185 miles per hour meant just over 2 hours outbound. Same coming back. 4 hours just flying, plus combat time, plus reserve for navigational errors or headwinds. It would be tight. Dangerously tight. I can make them work, O'Donnell said slowly, but I can't guarantee they won't cause problems. Different tanks mean different weight distribution, different drag characteristics, possible fuel flow issues. We'd be jury-rigging this, sir. Testing it in combat. We don't have time for proper testing, Mitchell said. Yamamoto flies tomorrow at 0600 their time. We'd need to launch at 0725 to make the intercept. That gives you, he checked his watch, 18 hours to modify 18 aircraft. 18 aircraft. 18 sets of drop tanks. 18 installation jobs that had never been done before on P-38s at Henderson Field. O'Donnell looked at his assistant crew chiefs. They looked back at him with expressions that said he was crazy. We'll need every mechanic we've got, O'Donnell said. Then I mean every swinging wrench on this island. No sleep tonight. Mitchell nodded. You'll have them. This mission is top priority. Whatever you need. What O'Donnell needed was a miracle, but he'd settle for 18 hours, some scavenged fuel tanks, and a lot of coffee. O'Donnell walked out of the operations tent with his 3 assistant crew chiefs, Corporal Eddie Vasquez, Corporal Jimmy Huang, and Private First Class Roy Clemens. They headed to the maintenance area where the fuel tanks were stored. The 165-gallon tanks were there, sitting in crates that had been shipped from Port Moresby 2 months ago. They'd been intended for P-39s, but the Arakabra squadrons had been redeployed before the tanks arrived, so they'd been sitting in storage, gathering dust and humidity. These are belly tanks, Vasquez observed. P-38s mount tanks on the wings, not the belly. P-38s mount a lot of things on the wings, O'Donnell replied. Bombs, rockets, cameras, the hard points are there. The question is whether these tanks will fit the mounting brackets and whether the fuel lines will connect properly. They pulled one of the tanks from its crate. It was a teardrop-shaped aluminum tank with mounting lugs on top and a fuel connector on the front. Simple, robust, designed to be expendable. Huang examined the mounting lugs. Boss, these lugs are spaced for P-39 wing mounts. The P-38 hard points are wider apart. O'Donnell measured the spacing with a tape measure, then compared it to the specifications for P-38 wing stations. Huang was right. The tanks wouldn't fit without modification. Can we fabricate adapter brackets? O'Donnell asked. Clemens, the youngest of the group but a gifted welder, nodded slowly. Yeah, but it'll take time. We need to cut steel, drill mounting holes, weld reinforcement plates. For 36 tanks, 2 per aircraft, we're looking at maybe 10, 12 hours just for fabrication. They didn't have 12 hours to spare. O'Donnell thought hard. There had to be a simpler solution. The whole point of drop tanks was that they were temporary, expendable. They didn't need to be perfect. They just needed to hold fuel, feed it to the engines, and not fall off prematurely. What if we don't use the standard hard points? He said slowly. The others looked at him. What if we mount them using the bomb shackles? P-38s carry bombs on wing racks all the time. The shackles are strong enough. The spacing might be closer to what we need, and we've got plenty of spare bomb racks. Vasquez grabbed a bomb shackle from a nearby parts bin and held it up to the fuel tank's mounting lugs. It wasn't a perfect match, but it was close. With some shimming and maybe some additional safety wire, it might work. It's crude, Vasquez said, and it's definitely not what Lockheed engineers had in mind. Lockheed engineers aren't here, O'Donnell replied. We are, and we've got 17 hours left. Huang grinned. You're talking about jury-rigging fuel tanks onto fighters using bomb racks and safety wire, then sending those fighters on the longest mission they've ever flown. The brass is going to call this reckless. Probably, O'Donnell agreed. But if it works, Yamamoto dies tomorrow. If we do nothing because we're worried about being reckless, 18 pilots sit on the ground while the man who planned Pearl Harbor flies past untouched. Clemens picked up the fuel tank. Let's get to work. By nightfall, every mechanic, armorer, and ground crew member at Henderson Field was working on the P-38s. O'Donnell had divided them into teams. Team 1, tank preparation. They inspected each fuel tank for leaks, corrosion, or damage. Several tanks failed inspection and had to be rejected. They cleaned fuel connectors, tested valves, and verified that the tanks could actually hold fuel without leaking. Nothing killed pilots faster than flying with faulty fuel systems. Team 2, bracket fabrication. Despite O'Donnell's hope that bomb shackles would work directly, they still needed custom adapter plates for about half the tanks. Clemens and 2 other welders set up a field workshop with acetylene torches, cutting steel plate and welding mounting brackets. Sparks flew in the darkness. The smell of hot metal filled the humid air. Team 3, aircraft preparation. Vasquez led this group. They removed the standard wing-mounted armament panels on each P-38 to access the hard points and bomb shackles. They cleaned corrosion from mounting points. They checked fuel line connections and verified that the auxiliary fuel system pumps were functional. Team 4, installation. Once tanks were ready and aircraft were prepped, this team mounted the tanks, connected fuel lines, and safety wired everything in place. This was the bottleneck operation. Each installation took about 45 minutes if everything went smoothly, and things rarely went smoothly. O'Donnell moved between teams, troubleshooting problems, making command decisions. At 2100 hours, they hit their first major problem. One of the fuel tanks didn't seal properly to the P-38's fuel line connector. Fuel dribbled out whenever they tried to fill it. The connector thread is stripped, Vasquez reported. This tank is junk. They didn't have spare tanks. O'Donnell examined the damaged threads. Can we tap it for a larger thread and use an adapter fitting, he asked. Maybe, but we don't have the right tap and die set for aviation fuel fittings. O'Donnell thought for a moment. Pull the connector assembly from one of the rejected tanks. If it's in good shape, we'll swap it out. It took an hour they couldn't afford, but they salvaged a good connector and got the tank working. At midnight, they had completed 8 aircraft. Halfway there, they were slowing down. Fatigue was setting in. Men were making small mistakes that had to be corrected. O'Donnell ordered a 15-minute break. Coffee was distributed. Some men collapsed on the ground, asleep before they even finished their coffee. Major Mitchell appeared, walking through the maintenance area, observing the work. "How's it going, Sergeant?" he asked quietly. "We'll make it, sir," O'Donnell replied, trying to sound more confident than he felt. "It'll be tight, but we'll have 18 aircraft ready by 0700. What's your biggest concern?" O'Donnell didn't hesitate. Fuel flow. These tanks were designed for single-engine P-39s. The P-38 has 2 engines pulling from the same auxiliary tank system. If the flow rate isn't sufficient, the engines could starve, especially at high power settings during combat. We won't know it's a problem until the planes are in the air. Mitchell absorbed that. If there's a fuel flow problem mid-mission, what happens? Best case, the pilot has to rely on internal tanks only, which means he won't make it home. Worst case, both engines quit over open ocean. That's not acceptable. No, sir, it's not, but it's the risk we're taking. We don't have time to test this properly. Mitchell was silent for a long moment. Then he said, "The decision to launch is mine. If these aircraft aren't safe, I need you to tell me. Don't let me send my pilots into a death trap just because we want to kill Yamamoto." O'Donnell met his eyes. "Sir, I'll tell you if I think it's a death trap. Right now I think it's risky but viable. The fuel system should work. The tanks are sound. The installations are as secure as we can make them in the time available, but I'd be lying if I said there's 0 chance of mechanical failure." "War doesn't offer 0 risk options," Mitchell replied. "Just better and worse gambles." "Keep working, Sergeant." At 0300 hours, they finished the 16th aircraft. At 0445, number 17 was done. At 0615, with barely an hour before scheduled launch, the last P-38 received its drop tanks. O'Donnell stepped back, looking at the row of modified fighters in the pre-dawn darkness. Each one carried 2 teardrop-shaped tanks under its wings. They looked awkward, jury-rigged, which is exactly what they were, but they might just work. "All aircraft ready for pre-flight inspection," he reported to Mitchell. Mitchell nodded. "Wake the pilots. ACT-4. The test 4 minutes 720 words, 0655 hours. The pilots gather for their final briefing. 18 men. 18 P-38s. One shot at the architect of Pearl Harbor." Mitchell laid out the mission profile one more time. They'd fly northwest at cruise power, hugging the ocean's surface to avoid Japanese radar. Navigation would be critical. 1 degree off course over 400 miles meant missing the Intercept entirely. They climbed to altitude only when they spotted Yamamoto's bomber. Lieutenant Rex Barber, one of the designated shooters, raised his hand. "Sir, what about these drop tanks? Most of us have never flown with externals before." Mitchell looked to O'Donnell, who'd been invited to the briefing. "Sergeant O'Donnell installed them overnight. He'll explain." O'Donnell stood, acutely aware that he was an enlisted man addressing a room full of officers. "Gentlemen, each of your aircraft now carries 2 165-gallon drop tanks mounted on the wing hardpoints. Total auxiliary fuel is 330 gallons, which extends your range to approximately 650 miles with reserve. These tanks were designed for P-39s, Lieutenant Lanfear said. Are they going to work on a twin-engine fighter? They'll work, O'Donnell said with more confidence than he felt. The fuel feeds into your auxiliary system just like standard P-38 drop tanks. You'll use auxiliary fuel first, then drop the tanks before engaging the enemy. Once you're on internal fuel, the aircraft handles normally. What if they don't drop? Another pilot asked. Each tank has a manual release in the cockpit. You pull the lever, they fall away. If the release mechanism fails, there's a backup cable release. If that fails, O'Donnell paused. You fly home with empty tanks still attached. It'll create drag and reduce your speed, but you'll still make it back. You said these installations were done overnight, Barber said. Have they been tested? This was a question O'Donnell had been dreading. No, sir. There wasn't time for flight testing. We've pressure-tested the fuel connections and verified the structural mounts, but this will be the first time these configurations fly. The room went very quiet. So we're test pilots now, someone muttered. Mitchell intervened. Gentlemen, I won't sugarcoat this. There's risk. But Sergeant O'Donnell's work gives us a chance at a target we'd never reach otherwise. The choice to fly is yours. Any man who wants a scrub can do so. No questions asked, no judgment. Nobody moved. Then let's mount up, Mitchell said. The pilots filed out to their aircraft. O'Donnell and his crew chief moved along the flight line doing final checks. O'Donnell approached Barber's aircraft, number 122. Barber was already in the cockpit, running through his pre-flight checklist. Sir, O'Donnell called up, check your drop tank fuel selector. Make sure it's set to feed from auxiliary first. Barber adjusted the selector. Got it. Hey, Sergeant, these tanks going to hold together? Yes, sir. You sure? O'Donnell looked him in the eye. Sir, I built them with my own hands. I checked every connection, every bracket, every safety wire. If they fail, it won't be because we cut corners or did sloppy work. Barber nodded. That's good enough for me. One by one, the P-38's engines coughed to life. Twin Allison V-1710s roaring, propellers spinning, the distinctive sound of lightnings preparing for combat. O'Donnell stood near the runway with his crew, watching. Vasquez lit a cigarette. Think they'll make it? They'll make it, O'Donnell replied. You don't sound certain. I'm not certain, but I'm hopeful. That's all we've got. At 0725 hours, Mitchell's P-38 began its takeoff roll. One by one, the others followed, lifting off from Henderson Field's pierced steel planking, climbing into the morning sky. O'Donnell counted them. 18 aircraft, all airborne, all systems apparently functioning. So far, so good. Now came the hard part, waiting. The mission would take roughly 4 hours round trip. 4 hours of not knowing if the fuel systems were working. 4 hours of wondering if his jury-rigged installations would hold together. 4 hours of carrying the weight that if something failed, men would die because of his work. Huang stood next to him. Nothing to do now but wait. Yeah, O'Donnell said quietly. Nothing but wait. 435 miles northwest of Guadalcanal. 0934 hours. Major Mitchell's flight had been navigating by dead reckoning for over 2 hours, skimming just 50 feet above the ocean to avoid radar detection. The drop tanks had performed flawlessly so far. Fuel was feeding properly. The installations were holding. Then Mitchell saw them. 2 Betty bombers escorted by 6 Zeros, exactly where intelligence said they'd be. One of those Bettys carried Admiral Yamamoto. "Bogies, 11 o'clock low," Mitchell called over the radio. "Shooters, go get him. Everybody else keep the Zeros off them." 4 P-38s, Barber, Lanfear, and 2 others, broke formation and climbed toward the Japanese aircraft. The remaining 14 turned to engage the Zero escorts. But there was a problem. The P-38s still had their drop tanks attached. Standard doctrine was to drop external tanks before combat. The tanks created drag, unbalanced the aircraft, and could even be dangerous if ruptured by gunfire. But if they dropped the tanks now, hundreds of miles from home, they wouldn't have enough fuel to make it back. Barber made a split-second decision. He'd engage with tanks still attached, dropped them only if he absolutely had to for maneuverability. It was reckless. It violated every training protocol. But this mission had been built on reckless decisions from the start. He pushed his throttles forward, climbing toward the lead Betty bomber. The Allison engine screamed. The drop tanks shuddered under the stress, but held. O'Donnell's installations were being tested in the worst possible way, high-speed combat maneuvering with full power settings. The Zero escorts reacted, diving to protect the bombers. Mitchell's covering flight intercepted them, and the sky erupted into a swirling dogfight. Barber closed on the Betty. His gun sight settled on the bomber's fuselage. He pressed the trigger. 450 caliber machine guns and 120mm cannon tore into the Betty. Pieces flew off the aircraft. Smoke poured from its right engine. The bomber nosed down, trying to reach the jungle canopy below. Barber followed, firing again. More hits. The Betty's tail section shredded, and then the bomber hit the jungle and exploded. "I got him," Barber shouted over the radio. "Bomber's down." "Which bomber?" There had been 2 Bettys. Lanfear was chasing the second bomber, which was desperately trying to escape at treetop level. He fired a long burst. The Betty's left wing separated from the fuselage. The aircraft cartwheeled into the jungle and exploded. Both bombers destroyed. One of them had definitely been carrying Yamamoto. "All shooters, break off," Mitchell ordered. "We're going home." The P-38s disengaged, turning southeast toward Guadalcanal. Now came the real test. They'd been flying for over 2 hours. They burned through the auxiliary fuel and were running on internal tanks. Some aircraft had dropped their external tanks during combat. Others, like Barber, still had them attached empty but creating drag. The fuel gauges showed less than half tanks. 400 miles to go. It was going to be desperately close. Back at Henderson Field, O'Donnell stood near the runway, scanning the sky. It was 1,130 hours. The mission had launched 4 hours ago. If everything had gone perfectly, the aircraft should be appearing soon. If things had gone wrong, they might never appear. Vasquez was listening to the radio traffic. Suddenly he looked up. "They're inbound. 10 minutes out." O'Donnell felt his stomach unclench slightly. Inbound meant they'd survived combat. But had they survived the fuel consumption? At 1,137 hours, the first P-38 appeared, Mitchell's aircraft. It came in fast, landing hard on the steel planking. Then another, and another. O'Donnell counted them as they landed. 1, 2, 3, 4, 5. Gaps now. Some aircraft were straggling. 6, 7. Another long gap. 8, 9, 10, 11. More gaps. Longer this time. 12, 13. Where were the others? 14 landed, its engine sputtering, nearly out of fuel. 15 came in trailing smoke from a damaged engine. 16, 17, and then nothing. Silence, except for the idling engines of landed aircraft. O'Donnell's heart sank. 1 aircraft missing. Vasquez was back on the radio. They're saying 1 pilot had to ditch offshore. Engine failure about 20 miles out. He's in his raft. Air-Sea Rescue is launching. 1 mechanical failure. Out of 18 aircraft flying a mission profile they'd never attempted before, With jury-rigged fuel tanks installed overnight, only one had failed to make it home, and the pilot was alive. It was, by any measure, a stunning success. Mitchell climbed out of his cockpit and walked directly to O'Donnell. "Sergeant, your fuel systems worked perfectly. Every aircraft that made it to the combat zone had full auxiliary fuel. The tanks fed properly. The installations held up under combat stress. You did it." O'Donnell felt weak with relief. "The aircraft had ditched, sir. Was it a fuel system failure?" "No. Combat damage to the coolant system. Not to do with your work." Barber approached, still in his flight suit, face flushed with adrenaline. "We got him, Sergeant. We got him, Sergeant. We got Yamamoto. Shot his bomber right out of the sky. And we made it 435 miles there and back because your tanks worked exactly like you said they would." O'Donnell nodded, unable to speak. They'd done it. The reckless plan had worked. The jury-rigged fuel tanks had performed. And the architect of Pearl Harbor was dead. Within days of the Yamamoto mission, word spread throughout the Pacific theater. P-38s could be modified for extended range using adapted drop tanks and improvised mounting systems. O'Donnell found himself pulled from Henderson Field and sent to Port Moresby, then to Brisbane, then to Pearl Harbor, training other maintenance units on his techniques. The military bureaucracy moved to formalize what he'd invented. Engineers from Lockheed arrived to study his bracket designs. They refined them, created technical drawings, established official installation procedures. Within weeks, standardized P-38 drop tank kits were being manufactured and shipped to every Lightning squadron in the Pacific. The fighters that had been limited to 350-mile combat radius could now reach 600 miles or more. The strategic implications were enormous. Japanese bases that had been safely out of range were now vulnerable. Rabaul could be hit by fighters operating from Guadalcanal. Wewak could be reached from Port Moresby. The expanding American air umbrella put pressure on Japanese logistics and morale across the entire theater. Long-range P-38 missions became routine. Escort missions deep into enemy territory. Fighter sweeps over Japanese airfields. Reconnaissance flights that penetrated hundreds of miles beyond friendly lines. And it had all started with one mechanic. 18 hours and a collection of fuel tanks designed for a different aircraft entirely. O'Donnell received a Bronze Star for his work. The citation read, "For meritorious achievement in connection with military operations against the enemy." Staff Sergeant O'Donnell's innovative engineering solutions enabled critical combat operations that significantly impacted the strategic situation in the Pacific theater. It was formal, bureaucratic language. It didn't capture the desperate overnight work, the uncertainty, the risk. But O'Donnell didn't need flowery citations. He'd done what needed doing. That was enough. What did bother him was the celebrity that came with it. Reporters wanted interviews. The brass wanted him at ceremonies. Other mechanics treated him like some kind of genius. "I'm not special," he'd insist. "I just adapted existing technology to a new application. Any competent mechanic could have done the same thing." But Vasquez, now promoted to sergeant himself, disagreed. "Boss, I'm a competent mechanic. I've been wrenching on aircraft as long as you have. And I never would have thought of using P-39 tanks on P-38s. I never would have had the guts to jury-rig 18 aircraft overnight for a mission that critical. You saw a solution nobody else saw, and you had the confidence to make it happen. It's not just competence. That's something else." O'Donnell didn't know what to say to that, so he changed the subject and got back to work. By late 1943, modified P-38s were operating across the Pacific from Alaska to Australia. The Yamamoto mission had proven the concept. The subsequent mass adoption had turned O'Donnell's improvised solution into standard doctrine. But success had a cost that nobody had fully anticipated. The extended range that made American fighters so effective also put pilots at greater risk. Longer missions meant more time over enemy territory, more exposure to anti-aircraft fire, more chances for mechanical failure far from friendly bases. And O'Donnell couldn't escape the feeling that some of those failures, some of those losses, traced back to his work. June 1944. O'Donnell was now stationed at Tacloban Airfield in the Philippines, overseeing maintenance for an entire fighter group. A P-38 limped back from a long-range mission over Luzon, trailing smoke. It crash-landed short of the runway, cartwheeling across the coral. The pilot, Lieutenant David Morrison, was pulled from the wreckage alive but badly injured. O'Donnell rushed to the crash site. The aircraft was a ruin, but he needed to understand what had failed. He found it quickly, a cracked fuel line connection on the drop tank mounting assembly. The crack had allowed fuel to leak onto the hot exhaust manifold, causing a fire that forced Morrison to abort and nearly killed him. O'Donnell examined the failed component. It was a bracket he personally designed, now manufactured by the thousands and installed on P-38s across the theater. The crack was a stress failure, metal fatigue from repeated installation and removal cycles, something he should have anticipated, something he could have prevented with better materials or reinforced design. Morrison would survive, but he'd never fly again. Burns covered 30% of his body. His career was over. That night, O'Donnell sat alone in his tent, staring at the failed bracket. Chaplain William McCarthy found him there. "Heard about Morrison," McCarthy said quietly. "Tough break." "It was my design that failed," O'Donnell replied, his voice flat. "My bracket, my engineering. I put that component on his aircraft. You also extended his combat range, gave him the fuel to complete missions that saved other pilots' lives. You can't take credit for the successes, but not the failures, Mac. It doesn't work that way. He's burned, scarred for life, because of my design." McCarthy sat down. "Let me ask you something. How many aircraft have used your drop tank systems? Thousands? Probably. And how many failures have there been? Total system failures, I mean." O'Donnell thought about it. "Maybe 24. Fuel leaks mostly. A few structural failures. Morrison's is the worst. 24 failures out of thousands of uses. That's a success rate most engineers would be proud of, but you're fixated on the failures, because the failures kill people. The successes save people," McCarthy countered. "Yamamoto is dead because of your work. How many American sailors did that save? Japanese plans compromised, morale shattered, strategic balance shifted. Your tanks made that possible. I keep thinking," he said slowly, "what if I'd designed the bracket differently? What if I'd specified thicker steel, or a different welding pattern, or additional reinforcement? Morrison would still be flying. Or maybe the bracket would have been heavier, changed the aircraft's performance, caused a different kind of failure. You can't know. Engineering is about trade-offs. You made the best decisions you could with the information and resources available. That's all anyone can do." O'Donnell wanted to believe that. He needed to believe that. But the image of Morrison's burned face stayed with him. The next morning, O'Donnell requisitioned steel and redesigned the bracket assembly. He added reinforcement gussets, specified higher-grade materials, changed the welding specifications. The new design went into production within a month. It was heavier, more expensive, but significantly more robust. There were no more stress failures. Morrison, recovering in a hospital in Brisbane, heard about the redesign. He wrote O'Donnell a letter. "Sarge, I heard you redesigned the bracket because of what happened to me. I appreciate that, but I want you to know something. I don't blame you. I signed up to fly fighters in a war. I knew the risks. Your drop tanks gave me the range to complete missions I couldn't have otherwise flown. They saved my wingmen more than once. Yes, one failed, and yes, I paid a price. But that doesn't erase all the good your work did. Don't carry guilt from me. I'm alive, and I'll heal. That's more than a lot of guys got. Keep doing what you do. You're good at it, and we need you." Dave O'Donnell read the letter 3 times. Then he folded it carefully and put it in his pocket. He carried it for the rest of the war. August 15, 1945. Japan surrendered. O'Donnell stood on the deck of a transport ship in Tokyo Bay, watching the surrender ceremony aboard the USS Missouri. It was surreal. The war he'd spent 4 years fighting was simply over. The P-38 Lightnings that had been so critical to Pacific air superiority were already being phased out. The newer P-51 Mustangs and the emerging jet fighters were the future. The Lightning's moment had passed. O'Donnell thought about all the missions those aircraft had flown, all the modifications he and thousands of other mechanics had made, all the improvised solutions to impossible problems. The drop tank modification he'd pioneered back in 1943 had become so standard, so normalized that nobody even thought about it anymore. Fighters just had extended range. The problem he'd solved had been erased so completely that it was hard to remember it had ever been a problem. Vasquez, who'd stayed with O'Donnell throughout the war, stood beside him. "What are you thinking, boss?" "I'm thinking about Yamamoto," O'Donnell replied. "April 1943. That mission started all of this. Changed everything. Think we did the right thing? Assassinating him?" O'Donnell had wrestled with that question for 2 years. Yamamoto had been a military target, legitimate under the rules of war. But it had been a calculated assassination, and it had required breaking Japanese codes, which the Americans then continued to exploit for the rest of the war. "I think we shortened the war," O'Donnell said finally. "After Yamamoto died, Japanese strategy became more erratic, less coordinated. Their naval operations never recovered the brilliance they'd had under his command. So yes, killing him saved lives in the long run. American lives, Japanese lives, civilian lives. The war ended sooner because of that mission, and your tanks made the mission possible." "My tanks made the mission possible," O'Donnell agreed. "So I'm responsible, at least partially, for everything that came after, the good and the bad." Vasquez was quiet for a moment. "That's a heavy thing to carry." "Yeah," O'Donnell said. "It is." But he'd learned to carry it. The guilt over failures like Morrison, the pride in successes like Yamamoto, the moral complexity of creating tools that kill people, even in service of ending a war that would have killed more people if it had continued. War didn't offer clean answers, just complicated trade-offs. On the Missouri's deck, General MacArthur was speaking. "It is my earnest hope, and indeed the hope of all mankind, that from this solemn occasion a better world shall emerge." O'Donnell hoped so too. He'd spent 4 years making weapons more effective, aircraft more lethal, military operations more successful. He'd been good at it, but he was tired of destruction, tired of designing systems whose purpose was killing, even necessary killing. He wanted to build things again, create things, fix things. The war was over. Finally, he could. ACT-9. Return home. 3 minutes 540 words. Marcus O'Donnell returned to Seattle in October 1945. Boeing welcomed him back, not to the maintenance hangar he'd left, but to their engineering department. The skills he developed in the Pacific, improvising solutions, working with limited resources, solving problems under pressure, translated well to post-war aircraft design. He worked on the B-47 Stratojet, the 707 commercial airliner, eventually becoming a senior engineer on the 747 program. He married, had 3 children, lived quietly in a suburban neighborhood where nobody knew about his wartime innovations. He never talked about the war. When his kids asked what he'd done, he'd say, "I fixed airplanes." Nothing exciting. His wife, Eleanor, once pressed him on it after finding his Bronze Star medal in a box in the attic. "Mac, you got a medal. You did something important. Why won't you talk about it?" O'Donnell was quiet for a long time. Finally he said, "I helped kill a man. An important man. An enemy, yes, but a man with a family, with people who respected him, who relied on him. I built the fuel systems that made his assassination possible. I'm proud we shortened the war. But I'm not proud of being an assassin's accomplice, even if it was the right thing to do." "You saved lives," Eleanor said gently. "I took a life," O'Donnell corrected. "Morrison's letter said not to feel guilty, and I've tried not to. But I can't escape the fact that everything I built, everything I designed was about destruction. Making aircraft go farther so they could kill more effectively. I was good at it. Really good. And that bothers me more than I can explain." Eleanor held his hand. "What you did mattered. You helped end the war. I know. But I'd rather be remembered for what I built afterward than what I built during." O'Donnell retired from Boeing in 1982. He died in 1994, age 76, from heart failure. His obituary in the Seattle Times mentioned his 40-year career at Boeing, his work on commercial jetliners, his family. It didn't mention the war. But in 2003, the Pacific Aviation Museum at Pearl Harbor opened a new exhibit on the Yamamoto mission. They'd obtained one of the original P-38s that flew that day, fully restored, complete with the jury-rigged drop tank mounts. The placard next to the aircraft explained the mission, the intelligence coup, the navigation challenge, and the fuel problem. And it mentioned Staff Sergeant Marcus O'Donnell, the mechanic who'd solved that problem in 18 hours with scavenged parts and improvised brackets. His daughter, visiting the museum, saw her father's name and wept. She'd never known. He'd never told her. The museum curator approached her. "Did you know him?" "He was my father," she replied, "but I never knew he'd done this. He changed the course of the Pacific War," the curator said. "One overnight modification that made the impossible possible." She looked at the aircraft, at the fuel tanks hanging under its wings, at the crude but functional brackets holding them in place. Simple, improvised, brilliant, just like the man who'd built them. And she understood, finally, why he'd never wanted to talk about it.